Okay, in this video I'm going to continue on with exercise 5A of the book Fundamental Applied Mathematics. We're on page number 118 and the question is 6. It reads, a cyclist covers 8 meters from rest in 8 seconds. The mass of the bicycle and cyclist combined are 80 kilos. There is a resistance of 20 newtons. Find the driving force applied to the rider. So the first thing we need to do is find out his acceleration. So let's just go back to chapter 2 where we had UVAST. So we know that we know that his initial speed, we don't know his initial speed, but we know it covers 8 meters from rest. Sorry, we do know his initial speed, it's 0. He covers 8 meters and he does it from rest, and he does it in 8 seconds. Like so. And we need to find his acceleration. So what can we do? If we used v is equal to u plus at, we'd find it's equal to 64. And we used s is equal to ut plus a half at squared, we're going to get that 8 is equal to 0 times 8 plus half times a, which is unknown, times t squared, which is 64. So we're going to get 8 is equal to 32a. A is equal to 8 over 32. Okay, so we're going to a is equal to a quarter meter per second squared, like so. So we have a quarter meters per second squared. So we now know his acceleration. What else do we know? I'm just going to note this down here. So we're told that we need to do a free body diagram. So let's just draw a sketch of what we have, the force that we need, or the force that we have. We're told the total mass of the whole thing is 80 kilos. So we apply F is equal to ma. So F is equal to 80 kilos times the acceleration, which is g, and g is in the negative j direction, so it's just going to be j hat. Because g is a negative number, well then that force is in negative j direction straight out. Alright, so what I can do is put in here that the weight vector is equal to 80 j hat. So we have a Newton's third law action-reaction pair here, so the normal vector is equal to negative 80 g. And that's in the j hat direction. Note that this is a positive number because we've defined gravity as a negative number. Next, we're told that there is a resistance of 20 newtons. So back this way, I'm going to call the resistance. So R, the magnitude of which is equal to 20, or we could say the R vector is equal to negative 20 I hat, like so. Now we need to find, what else we need to find? I have to find the driving force applied by the driver. So the driving force, of course, is going to have the driver move to the right. So I'm just going to call it driving force, and I'm going to call it equal to x I hat, like so. So let's just apply Newton's second law, that the sum of the forces is equal to the mass times the acceleration. Alright, so it's pretty straightforward. So we know that the sum of the forces is equal to ma. Okay, so we know the sum of the forces are as follows. Negative 20 I hat, positive x I hat, positive 80 g j hat, negative 80 g j hat. Alright, of course these two just cancel, and we're left with negative 20 I hat plus x I hat is equal to ma is equal to 80 a. But we found out what the acceleration was. It was a quarter. So we just plug that straight in. I know I'm doing a lot of rubbing out, but there's no point writing everything. Alright, so that turns out that negative 20i plus xi is equal to 20. Therefore, x is equal to 40 I hat. It's a force, therefore we have 40 newtons. So let's just check that at the back of the book. So we have 5A question 6. And that is correct. So thanks for watching. Please pass it on to your friends and subscribe to my channel.